Yes. Hello friends, welcome to the session. Continuation of chapter 7, that is DC to DC converter. In the last sessions, I discussed about the concepts with respect to what is buck regulator and boost regulator and buck boost regulator. In detailed analysis I given with respect to continuous mode, discontinuous mode, and practical conditions are considered. What is the operation of boost regulator and buck boost regulator? All these concepts I give. Yes. Now, in this session, from this session, we continue with based on buck regulator and boost regulator and buck boost regulator. We will solve some classroom workbook questions. Okay. Then all of you take the classroom workbook. See the workbook all of you take. This is chapter 7, DC to DC converters, that is choppers. Under the topics of see the first topic, buck regulator, boost regulator and buck boost regulator. I'm discussing classroom workbook on what are the topics. The topics are buck regulator, a boost regulator. See the workbook, all of you. Boost regulator, then buck boost regulator. Based on these topics, we are solving the question. And buck boost regulator. Okay. Buck regulator, boost regulator, buck boost regulator. Shall we start? Let's see the question number 1. In the chopper circuit shown in figure, the input DC voltage has a constant value Vs. The output voltage V0 is assumed ripple free. The switch S is operated with a switching time period T and duty ratio D. What is the value of D at the boundary of continuous and discontinuous conduction of the induction current IL? That means you want to find what is the duty cycle at boundary condition. What is the duty cycle at boundary condition? Can you tell me, given chopper is which chopper? Given is which one? Yes, it is a step down chopper because inductor is at load side. Whatever the symbol is there, that is not thyristor. You correct that one, that is the diode. Okay, it's a diode, it's not a thyristor. Okay, maybe by mistake it is given as a thyristor, but it is a diode. Then you want to find what is the duty cycle at boundary condition. What is the duty cycle at boundary condition? What are the options are given? This is question number 1. What are the options are given? Option A is D equal to 1 minus Vs by V0. Option B, D equal to 2L by RT. Option C, what is given? D equal to 1 minus 2L by RT. Option D, D equal to RT by L. These are the options given. You want to find what is the duty cycle at boundary condition. We know that at a boundary condition, we are derived one formula, that is critical inductance. And this formula, the options also given in terms of critical inductance. Can you solve like this? What is the solution for this problem? What is the solution for this problem? We know that at boundary, at boundary, whatever the inductance is defined, that is critical inductance. Given is step down chopper na, given is step down chopper. How to identify the chopper, that I already told. What is the critical inductance? R into 1 minus D by R into 1 minus D by 2F. This formula you know. At a boundary condition. This is derived at a boundary condition only. Can you solve like this? 2 into LF is equal to R into 1 minus D. Shall we write like this? 2L by T equal to R into 1 minus D. Now from this, what is 1 minus D equal to? RT by 2L. Then what is D equal to? 1 minus, what is D equal to, you tell me? D equal to 1 minus RT by 2L. This is the duty cycle at boundary condition. But I am writing 2L into F equal to R into 1 minus D. From this 1 minus D equal to this one, 1 minus D equal to 2L by RT. Sorry, this is 2L by RT. Then from this, what is D, you tell me? 1 minus 2L by RT. Then which option is correct? Yes, option C is correct. The duty cycle at boundary condition D equal to 1 minus 2L by RT. This formula derivation you already know. Okay, this is at boundary condition. At boundary condition, what I given? Delta, whatever the peak to peak ripple current and average inductor current, that relation I given, based on that you tell. At a boundary condition means IL minima you can equate to 0. IL minima you can equate to 0 means IL equal delta IL by 2. IL equal to delta IL by 2. What is delta IL? You know. From that it is derived. But no need of that fundamental itself. This minimum formula you know. From that also you can write directly. What is the duty? Clear? Answer. Quick. Note down. Over. See the one more question. Second question. Yes. Figure shows a chopper operating from 100 volts DC input. The duty ratio of the main switch S is 0.8. The load is sufficiently inductive so that load current is ripple free. The average current through the diode D under steady state is dash. Figure shows a chopper operating from a 100 volts DC input. The duty ratio of the main switch S is 0.8. For the question number 2, the duty ratio of the main switch is 0.8. Okay. Given 100 volts DC input, what is VDC equal to 100 volts? DC input is 100 volts. The load is sufficiently inductive so that load current is ripple free. Load current is ripple free means that is continuous mode. This is a problem under continuous mode. The average current through the diode D under steady state is that. Can you tell given chopper is? See the circuit all of you. No need to draw again here. It is there in workbook now that you see what is the chopper circuit. Instead of switch, what it is given? Thyristor. Thyristor is used as a switch. I told any power semiconductor is used as a switch. Instead of switch symbol, thyristor is used as a switch. Inductor is at load side na. That's why given is which chopper? Step down chopper or buck regulator. In step down chopper or buck regulator, you want to find average current through the diode. Then in a step down chopper or buck regulator, can you tell what is the average current through the diode? ID average equal to average current through the diode. That is 1 minus D into IL. This formula you know. 1 minus D into IL. Okay. But here in step down chopper, IL is nothing but IL average. IL average. IL average is equal to I naught. Therefore, what is ID average? ID average equal to 1 minus D into I naught. Then you want to find I naught. How to find I naught? You tell me. I naught equal to V naught by R. Then how to calculate V naught? V naught equal to dVs. Where the duty ratio is given 0.8. Vs is given 100 volts. Then 0.8 into 100. Then how much you get? 80 volts. Then what is I naught equal to V naught by R? That is 80 by what the resistance is given in the circuit that you see 10 ohm. Then how much you get? 8 ampere. This is not the you want to calculate. You want to find what is the average current to the diode under steady state. What is the average current? ID average equal to what is the formula? I naught into that is 1 minus 0.8 into 8. Then how much you get? 1.6 ampere. Then which option is correct? Option A is correct. What the options are given? Option A is 1.6 ampere. Option B is 6.4 ampere. Option C is how much it given? 8 ampere. Option D is how much it given? 10 ampere. Then what is your answer? Option A, 1.6 ampere. Clear? That you concentrate. Quick. Want to find average current through the diode. The average current, how you are getting this formula that I already told. Diode will conduct during which time? Off time. IL into TF by T. But here IL average is equal to I naught because it is a which regulator? Buck regulator. Oh, no. Okay. See the question number 3. Concentrate quick. Yeah. An ideal chopper operating at a frequency of 500 Hz supplies a load having resistance of 3 ohms and inductance of 9 millihenry from a 60 volts battery. The mean value of load voltage for on-off ratio of 4 by 1, assuming that the load is shunted by perfect commutating diode and battery is lossless. What the DC battery voltage is given? The supply voltage is given is how much? 60 volts. Operated at a frequency of how much? 500 Hz. Okay. Then duty cycle is how much? Then on-off ratio is given. T on by T off equal to how much it is given? 4 by 1. T on by T off equal to 4 by 1. Then you want to find what is the duty cycle? The mean value of load voltage. The mean value of load voltage. But to identify the given is which chopper, circuit is not given. But in bracket one data is given. Assuming that the load is shunted by perfect commutating diode. S. Across the load there is a diode is there. Across the load diode is there means which chopper? S. Step down chopper or buck regulator. Then you want to find the average output voltage. Want to find average output voltage. What are the options are given? Option A is 240 volts. Yes. Option B is 48 volts. Option C is 15 volts. Then what is the option D? Option D is 4 volts. This data is given. These are the options. Then that means across the load a battery is shunted. Across the load a diode is shunted. That means which chopper? Buck regulator. In buck regulator what is V naught equal to dVs? dVdC or dVs. Okay. Then to find the duty cycle, to find the average voltage, you know that duty cycle. But duty cycle is directly is not given. But to calculate duty cycle data is given. On time by off time. What is T on by T off? That I told. It is also called Mark II space ratio. On time by off time is also called Mark II space ratio. That I told already. On means mark. Off means space. What is T on? You write dt. What is T off? You write 1 minus d into t. So many times this formula I given. Okay, d by 1 minus d equal to how much it is given? 4 by 1. Then cross multiply this. D equal to 4 minus 4d. Then what is the 5d equal to 4? Then what is the d equal to 4 by 5? That is 0.8. But you want average output voltage na? Then what is the average output voltage? V naught equal to dVdC. then 0.8 into how much? 60. Then D 48 volts. Then average output voltage equal to 48 volts. Option B is correct. Simple. Quick. These models are asking in GATE or another other competitive point of view also. Important models all these. Okay, clear? See the one more question. Four. See the question number 4. All of you read the question quick. Same topic, question number 4. Figure 1 shows the circuit diagram of chopper. The switch S is in the circuit in figure 1 is switched such that voltage VD across the diagram as the wave shape as shown in figure 2. The capacitance C is large so that the voltage across is constant. If switch S and diode are ideal, the peak to peak ripple current in the inductor current is dash. First you identify given chopper is which chopper? S. It is step down chopper or buck regulator because inductor at the load side or diode across the load is there. That's why it is a step down chopper or buck regulator. That is the figure 1. No need to draw the figure, but you see the waveform is also given. This is the voltage across the diode waveform. Voltage across the diode is nothing but a voltage across the load because inductor is because diode is connected across the load. This voltage across the diode waveform. Okay. If it is on state, this is on time. This is how much it is given? 0.05. And this is 0.1. This is 0.1. And this is 0.15. This T is given in milliseconds. It is in milliseconds. Okay. This how much it is given? 100 volts. During on state, if the switch is on state, the voltage is 100 volts. If the switch is off state, then it is 0 voltage. If the switch is off state means diode will conduct. If the diode will conduct, voltage across the diode is 0. If the switch is on state means the voltage is off state. The diode is under off state. That voltage will appear across the diode. Okay. But given chopper is step down chopper, you want to find peak to peak ripple current in the inductor. Can you tell what is the peak to peak ripple current in the inductor? Delta IL. The peak to peak ripple current in the inductor equal to, or the formula is D into 1 minus D into Vs by Fl. This formula you know. D into 1 minus D into Vs by Fl. Frequency is given. Frequency is not given. But to calculate frequency, this data, this waveform is given. From this, can you tell what is the on time? From this waveform, on time equal to 0.05 milliseconds. Instead of giving duty cycle directly, this waveform is given. From that data, you calculate what is the switching frequency and what is the duty cycle. What is the total time period? 0.1 milliseconds. Then from this, can you calculate what is the duty cycle? T on by T. That is 0.05 by 0.1. How much you get? 0.5. Duty cycle is 0.5. T on by T. Then what is the frequency equal to 1 by T? That is 1 by 0.1 into 10 power minus 3. Then how much you get? 10 kilohertz. Okay. Then this frequency you know. What is the duty cycle you know. Then you find what is the peak to peak ripple current. That is 0.5 into 1 minus 0.5 is 0.5. What the supply voltage is given? The supply voltage is given in the circuit now. I'm not drawing that one. That you know in the material. Okay, in the class workbook you know now. That is 100 by what is frequency? Frequency calculated 10 kilohertz. What the inductance? See the circuit. In the inductance, how much? In the circuit, how much inductance is given? Then how much you get? Okay, this we get 2.5 amperes now. This how much we can get by simplifying this one? We get 2.5 amperes. This is a peak to peak ripple current. Simple. Duty cycle and frequency calculated from this waveform. This waveform is given. Okay, then you can use that data here. Then you can get peak to peak ripple. Clear? Quick order. Read the question. In the circuit shown, an ideal switch S is operated at 100 kHz with a duty ratio of 50%. Given that is delta IC is 1.6 amperes peak to peak and I naught is 5 ampere DC. The peak current in the switch is dash. Okay, you correct that is not delta IC. Actually, it is a delta IL. Okay, the peak to peak capacitor ripple current, but taking peak to peak capacitor ripple current is we are not calculating. We know that what is the peak current to the switch? Peak current to the switch is nothing but a. What is the solution for this one? That I given. Given is which chopper? You tell me. Yes. See the circuit. Given is which chopper? Step down, because it is at a inductor is at load side and diode across the load. Then what is the peak current to the switch? Peak current to the switch is this concept I already explained. Peak current to the switch is nothing but a peak ISW equal to IL max. ISWP equal to IL max. Peak current to the switch is nothing. Peak current to the inductor. Then what is the peak current to the switch? ISWP equal to IL plus delta IL by 2. IL plus delta IL by 2. That formula you know. Then you find average inductor current. It is given is step down now. I naught plus delta IL by 2. I naught plus delta IL by 2. The DC current is given 5 amperes. Delta IL is how much is given? Peak to peak ripple current 1.6 by 2. How much you get? 5.8 amperes. The peak current through the switch is nothing but a 5.8 amperes. You take that is delta IC is not. Actually it is a delta IL. Peak to peak ripple current in the inductor. Then that is 5.8 amperes. Clear? Quick note down. Simple. All these analysis I given. No need to derive all these formulas again. See the concept. Whatever the concept I given, that you listen. Then you already know what is the concept. Then it's easy to solve any question. See the question number 6. A chopper is employed to charge a battery as shown in figure. Okay. The charging current is 5 amperes. The duty ratio is 0.2. The chopper output voltage is also shown in figure. The peak to peak ripple current in the charging current is dash. You want to find what the peak to peak ripple current in the charging. What the circuit it is given? You tell me. What the options are given? First you see the given. This is the given circuit. This is chopper. This is chopper is given, and this is L equal to 20 millihenry. L equal to 20 millihenry. This is 5 volts DC. This is DC, VDC. Sorry, this is VDC. Supply voltage is VDC. This L is 20 millihenry and this is 5 amperes. This is 5 amperes. And the battery is 12 volts. batteries to charge the battery. See, and data is given like this. The chopper output voltage also shown in figure. This is output voltage. This is 60 volts if the chopper is on, and this is chopper is off. Again it is 60 volts. This is given is 200 microseconds. On time is given as, this is given as 200 microseconds, and this total time is given as 1 millisecond. This is given as 1 millisecond. In this you find the peak to peak ripple current. See, in every chopper how to calculate peak to peak ripple current, the data is given. But by seeing this chopper circuit directly we cannot identify is it a buck regulator or boost regulator or buck boost regulator. Okay, then better to go for fundamental. See, once perfectly you know what is the given chopper, you know formulas. Again no need to derive. Directly you can apply the formula. Okay, if you forget that formula, then go for concept. The concept in detail that I already given. Okay, then here I don't know about it is a buck regulator or buck boost regulator or like that. I'm not identifying this one. That's why if you think like this, here VDC we are applying now. Here VDC we are applying at source side inductor. At source side inductor means what is that chopper? Boost regulator. A step up chopper. But it is applying the what type of load? Battery load it is applying. Battery load it is applying. Directly also you can solve like that if you think. But if you have any difficulty, sir, I am not identifying what is this type of chopper, then go for concept. Then to calculate peak to peak ripple current, you take on or off. Chopper is on you take, or chopper is off you take. Can you tell if the chopper is on? If the chopper is on, okay, let the voltage across the load is V0. Okay, let the voltage across the load is V0. Okay, if the chopper is on, you know the, if the chopper is on means how we can write VL equal to, if the chopper is on, VL equal to VDC minus V0. VDC minus V0. If the chopper is on, VL equal to VDC minus V0. This is the waveform corresponding to, this is VDC. This is VDC is given. This is VDC. Chopper is on, VL equal to VDC minus V0. Yes. Tell. Then you want to find how to write VL equal to L into di by dt. L into di by dt equal to VDC minus V0. VDC minus V0. This is VL. This is V0. Then VL equal to VDC minus V0. Okay. Shall we write like this? L into delta I. What is dt? During on time I will take. T on is nothing but a dt. VDC is how much? 60. V0 is how much? 12. This you take V0 na. This you take VL na. Apply KVL. If the switch is on, then only current is applying to the load. Then current is applying to the battery. Then VL plus V0 equal to VDC. Then VDC minus V0. Okay. Shall we write like this? L into delta I equal to, this is how much it is, 48 volts we can get. 48 into dt. Okay. Then you want to find delta I na. Delta I equal to 48 into dt by L. Dt by L. Then you want to find what is the frequency, what is the time, what is the total time, you can see that 1 millisecond. But you want to find duty cycle. The duty ratio is given is 0.2. Duty ratio is given is 0.2. Then 48 into 0.2 into 200 microseconds. Sorry, 1 millisecond. 1 into 10 to the power of minus 3 by, what inductance is given? 20 millihenry. 20 into 10 to the power of minus 3. This cancel. Then how much you get? You tell me. 9.6 by 20. 9.6 by 20. 9.6 by 20 means how much you get? 0.48 ampere. This is the peak to peak. This is delta L, you write. Delta L. Peak to peak ripple current. Peak to peak ripple current equal to peak to peak inductor ripple current is nothing but a peak to peak ripple current in the charging current. This is charging through inductor only, na battery charging through inductor, na. Whatever the ripple current in the charging current is nothing but that is the ripple current in the inductor. Then how much you get? 0.48 ampere. Yes. Okay. If you assume that this is the supply voltage we are thinking, then inductor is connected at supply side, then it is a boost regulator, then V0 equal to dVs by FL. Delta L equal to dVs by FL. Delta L equal to dVs by FL. Apply directly like that, then we can get same answer, 0.48. Clear? But I am solving this question from the fundamental. This how we are deriving the delta L, that you know. Okay, from that I express. Okay, quick note down. Okay, clear? See the common data question. This is for question number 7 and 8. This is the common data question for 7 and 8. Read the question quick. For question number 7 and 8, this is the common data question. See the data. In the figure shown below, the chopper feeds a resistive load from a battery source. MOSFET Q is switched at 250 kHz with a duty ratio of 0.4. All elements of the circuits are assumed to be ideal. The seventh question is, the peak to peak source current ripple in amperes is dash. The peak to peak source current ripple is nothing but a peak to peak inductor ripple current, because source and inductor is in the series. The average source current in amperes in steady state is dash. You want to find average source current in amperes under steady state. First you tell me. I'm not drawing the circuit. See the circuit, all of you. Can you tell given chopper is which chopper? Yes, boost regulator or step up chopper, because inductor is at load side. Inductor is at load side. Instead of normal switch, here instead of switch, which device is used as switch here? Yes, MOSFET. MOSFET is used as a switch. Then this is common data question. For seventh question, I am giving the answer. You want to find what is the peak to peak source current. Peak to peak source current is nothing but a peak to peak inductor ripple current. In a boost regulator, what is delta L equal to dVs by FL? Okay. For this, I am giving the solution. dVs by FL. dVs by FL means what the supply voltage is given? 12 volts. Then what the duty ratio is given? 0.4. Inductance is also given. Frequency is also given. To simplify this, how much we can get? D is 0.4. Supply voltage is 12 volts. Frequency how much? 250 kHz. 250 into 10 cube. Then inductance is how much? Inductance is 100 microhenry. 100 into 10 power minus 6. Then you simplify this one, we can get 0.192 ampere. 0.192 ampere. Then which option is correct? Then option C is correct. Which option is correct? Option C is correct. 0.192 amperes we can get. Because it is a boost regulator, dVs by FL. If you are not remember this formula, go for chopper is on or switch is on. Apply KVL. From this you calculate delta L. That is also one procedure. Okay, but how to calculate this I given already. Then see the 8th question. One more question. This is a common data question. For the same data, the average source current equal to dash. To calculate average source current, what is the concept? Input power equal to output power. Wherever we are calculating the average source current, assume that lossless chopper. Input power equal to output power. How to write input power? VDC into IS is equal to output power. You can write V0 into I0. Then VDC into IS equal to, how to write V0? V0 is VDC by 1 minus D into I0. Then VDC cancel. Then what is the average source current equal to? I0 by 1 minus D. Now you want to calculate I0. Then how to calculate I0? First we calculate V0. Then what is V0 equal to? VDC by 1 minus D. What is VDC? 12. 1 minus 0.4. 12 by 0.6. How much you get? 20 volts. What is I0 equal to? 20 by 20. Resistance is given now 1 ampere. See the circuit. In the circuit resistance is given, that is 1 ampere we can get. Once you know the I0 is 1 ampere, then what is IS equal to? I0 by 1 minus D. That is 1 by 1 minus 0.4. That is 1 by 0.6. 10 by 6. Then how much you get? This is 5 by 3 amperes. The average source current equal to 5 by 3 ampere. Then which option is correct? The option B is correct. Okay, quick note down. Quick. See the question number 9. All of you read the question. A chopper is supplying 660 volts from 220 volts DC source. A chopper is supplying 660 volts from 220 volts DC source. If the non-conduction time of thyristor chopper, here thyristor is used as a switch, 100 microseconds, then the on time of the chopper will be dash. If the non-conduction time of thyristor chopper is 100 microseconds, then the on time of the chopper will be dash. Simple question. A chopper is supplying 660 volts from 220 volts DC source. Then what is VDC equal to? 220 volts. What is V0 equal to? 660 volts. Let's concentrate. If the non-conduction time of chopper T of equal to how much? 100 microseconds. Then what is the on time you want to calculate? On time you want to calculate. Yes. Can you tell me? Given is which chopper? How to identify? Circuit is not given. From the data you want to identify. Given is which chopper? Then V0 is greater than VDC. No? V0 is greater than VDC means it is a step up chopper. It is a step up chopper. Then we want to solve this question in continuous mode only, but don't confuse with continuous mode or discontinuous mode. If data is available to check the, I told already, if the data is available to check the continuous or discontinuous mode, then you can check. Or otherwise you take continuous mode. If it is mentioned that discontinuous mode, then only you take discontinuous mode. So in most of all the problems, it is mentioned that triple free, large inductor, constant, like that. It is mentioned that all these are continuous mode only. Let us see 1 or 2 problems in discontinuous mode. Then we get idea how the problem will appear in discontinuous mode. Okay, if the data is available, then you can check how to check the continuous and discontinuous. Also, I told already. Okay, then V0 is greater than VDC, step up chopper. V0 greater than VDC, step up chopper means what is V0 equal to VDC by 1 minus D. What is V0? 660 volts. What is VDC? 220 volts by 1 minus D. What is 1 minus D equal to 1 by 3? What is D equal to 2 by 3? But off time is given, you want to find on time. But you know this formula. What is on time by off time? On time by off time equal to D by 1 minus D. Then T on equal to What is D? D is 2 by 3. What is 1 minus D? 1 by 3 into T of. T of is how much? 100 microseconds. Then what is T on you can get? T on equal to 200 microseconds over. This is on time. This model also asks in compute. The on time of the chopper equal to 200 microseconds. Clear? Concentrate. Quick. Let's see the question number 10. See the question number 10. Over. Quick. All of you read the question. A self-commutating switch operated at a duty cycle delta is used to control the load voltage as shown in figure. Under steady state operating conditions, the average voltage across the inductor and the capacitor respectively dash. Okay, this is the given circuit. This is VL. L is the inductor. This is switch. The switch is operated at a duty cycle of delta. Instead of D, it is given as a delta. Then this is diode and this is capacitor connected across the load RL. This is C. This is D. The supply voltage is VDC. Now can you tell what is the average voltage across the inductor and the capacitor respectively under steady state condition? We know that under steady state condition means switch is on and switch is off. You take one time of operation, one time period of operation. When the switch is on state, inductor storing the energy. When the switch is off state, inductor releasing the energy. That means whatever the energy stored by the inductor is equal to energy released by the inductor. Storing energy equal to releasing energy means then under steady state condition, what is the average voltage across the inductor? 0. That is correct. And it is also asked, you find the average voltage across the capacitor also. Average voltage across the capacitor is nothing but average voltage across the load under steady state condition. Under steady state condition means switch is on and switch is off, one time period of operation. In one time period of operation, whatever the voltage is calculated across the load, that is the voltage across the capacitor. Yes, sir. Now you tell me, what is this chopper? I am not deriving this one. This I already given in the concept. What is this chopper? It is a boost regulator. In boost regulator, what is the voltage across the load? Voltage across, this is inductor. What is the average voltage across the load? Average voltage across the load equal to VDC by 1 minus delta. Actually it is this in the concept I given VDC by 1 minus D. But in the problem, instead of D, what it is given delta. VDC by 1 minus delta. This is equal to voltage across the capacitor. Then which option is correct? VL is 0. Then VC equal to VDC by 1 minus delta. Option A is correct. Simple. But no need to make any derivation. This you know already given. If you want derivation, see the concept. Quick, no doubt. Steady state condition means one time period of operation. In one time period of operation, one on and one off. What is the voltage across the inductor? What is the voltage across the capacitor? That you are calculating. Here. Over. See the question number 11. Continue. Yes. For the switching converter shown in the following figure, assume steady state operation. Also assume that the components are ideal. The inductor current is always positive and continuous, and switching period is Ts. Okay, this is boost regulator. Okay. See the question. I am explaining question number 11. The inductor current is always positive and continuous, and switching period is Ts. If the voltage VL is as shown, the duty cycle of the switch S is dash. See the given circuit is, this is the given circuit, positive, negative, this is V in, and this is the inductor, plus minus VL, this is L, and the switch is given like this. Instead of switch, it is MOSFET is used as a switch. This is a given switch, and this is diode, and capacitor is connected across the load, and this is the resistor. Okay, and the voltage across the inductor waveform is also given. This is the voltage across the inductor waveform. Voltage across the inductor waveform is also given. Then this is how much? 15 volts, and this is minus 45 volts. This is voltage across the inductor waveform. This is VL. This is time axis. Okay. This is one switching period. One switching period is nothing but a Ts. One switching period is nothing but one Ts period. Yeah, this is during on state. This is during off state. This is during off state. Then you find what is the duty cycle? S. Here, if you want to find duty cycle in this problem is, because voltage across the inductor is given, from that data you calculate the duty cycle only. During on state and off state is given. From the circuit you write the equations for KVL equations for during on state and off state. Given is which regulator? Boost regulator. Here this is Vn or VDC. I am assuming that VDC. Vn or take VDC. During on state, during on state, during on state, during T on. During switch is on means diode is off. Then what is this relation? You know, VL equal to VDC. What is VDC? You can get VL equal to VDC. This is how much? 15 volts.